Good evening, everyone. Dear authors and invited guests, welcome to the technical session 4F. My name is Siddhi Auti and I'll be your moderator for today's session. On the behalf of Global Knowledge Research Foundation, it is my great pleasure to welcome you to the 9th International Congress on Information and Communication Technology. The ninth edition of the conference is being organized in a hybrid mode. The physical event was organized in London on 19th and 20th of Feb, and the virtual event will be organized today and tomorrow via Zoom meetings, 21st and 22nd Feb 2024. I hope you will enjoy the knowledgeable and interactive session throughout the day. In this session, we have seven presentations in this session, and each presenter will be given a time span of 12 minutes, and 3 minutes will be given for the Q&A part. So I request all the participants to wrap up your presentation within the time limit of 12 minutes. There is another request to all the participants that you all stay connected with us until I say the closing remarks. If you have any queries or technical issues, you can contact me. You can text me in the chat box, and I'll be solving those issues. Just before we get started with the presentations, I would like to introduce you all with the chair for today's session, uh, Dr. Varsha Zadav ma'am. Varsha ma'am is currently working as assistant professor in artificial intelligence and data science department of Vishwakarma Institute of Information Technology, India. She completed her PhD in computer engineering from Dr. Babasaheb Ambedkar Marathwada University, Aurangabad. She has a 19 plus years of experience in teaching, and she was also my professor, a DSA professor in the last sem. Welcome, ma'am. Hello.
Yes, hello. Am I audible?
Am I audible?
Hello.
Yes, ma'am.
Yes. Thank you.
Hello.
Thank you, Siddhi, for your pretty introduction. Yes, and I would like
Yes,
to.
ma'am. Now we will start.
Yes. Please continue.
Okay, ma'am. We will start with the presentations now. Riddhi, can you please the next slide, the presentation slide. Okay, so the first presenter for today's session is Abdul ma'am. Actually, ma'am, are you present in the meeting? Abdul ma'am. So if the participant is not present, we'll proceed to the next participant. So the next slide, please.
Yes. Can I share my screen?
Oh, okay. I'm so sorry, ma'am. She was there in the meeting. Please take the previous slide only. We couldn't hear you actually.
Yeah. Okay.
Okay. Ma'am, you may start with your presentation. The paper title for first presenter is a unit cell element for reflect arrays based on the bow tie shape. You may start with your presentation now. We'll stop the screen sharing.
I can share my presentation. Yeah. Okay.
Hello and welcome to all attendees. I would like to introduce myself. My name is Rusul Amr Abdel Jabbar, a master's student from Iraq studying at University of the Ninawa. The title of research a unit cell element for reflector arrays based on the body shape, submitted by Prof. Khalid Hassan Said Marim and me. As introduction for the reflector array antenna have witnessed increased interest in the last 2 decades as they offer number one good trade-off between conventional parabolic reflectors and planar phase array. Number two, low white. Number three, flat profile. The element of the reflector array should supply the required phase distribution across the array surface so that the function of the parabolic reflector is achieved by planar surface of the reflector array. Number two, the element of the reflector array should have linear phase variation with the frequency and the size of the element. So, to control the phase reflection of the element of the reflector array by three methods. Number one, the variable size patch. Number two, fixed size patch with the variable stub length. Number three, fixed side rotate element. And the purpose unit cell in this design was bow-tie antenna because to the large bandwidth compared to the other types of the dipoles, and here the shape of the classic bow-tie. And there is a three main parameter, namely for the bow-tie design: the horizontal dimension named by 2a, and the vertical dimension named by b, and the theta is the tip of the two triangles. And the element design is built on substrate type of FR4 with the permittivity 4.3 and tangulus 0.025, and the height of the substrate is 3.2 millimeter, and this design was modulated using CST microwave. Now we take some tests on the bow tie to analysis and studying the as a unit cell for reflector array. In the first set of the test, the width was kept constant at 8 value while the height was varied. Here figures is the result from CST. Figure 1 explains the variation of the reflection coefficient magnitude with the frequency for the various value of the beam at the width of the bow tie is 8 value. Figure 2 explains the variation of the reflection coefficient phase with the frequency for the various value of the beam at fixed width at 8 value. It can see from these figures that response show a small tip of the about 6 dB, which indicated a resonance whose frequency decreases as the height is increased. This can be related to the fact that larger object resonate at lower frequency. And the second stage of the simulation was the height of the bow tie is constant at 4 value, while the width of the bow tie was varied. See the shape of the bow tie. We can see from result a faster change in the resonant frequency with the width of the bow tie than change in the resonant frequency with the height of the bow tie. Also, the phase response shifts to the lower frequency as the height B is increased. These figures compare the phase response of the bow tie unit cell. Both responses were at the frequency of 6 GHz. The table in the next slide shows a comparison of the phase response performance parameter for the two set simulation of the changing the dimension of the bow tie element. We can see the phase of the reflection coefficient change of the less than 360 degree. And also, we can see in the test or when the variable width and fixed height of the element has sharper slope but has larger phase range as compared to the first case. Now we compare the bow tie with the other basic shape as square and rectangular and dipole. It can be seen here that the square shape have over the smallest face slope followed by the rectangular and bow tie, while the bow tie and the dipole have over the largest face slope. However, the bow tie has shown a larger phase range. The reason for this finding can be attributed to the fact that the dipole and the bow tie shapes have sharp edges compared to the rectangular and square shapes. In the last, the conclusion of this research, number one, the reflection coefficient in magnitude and phase were obtained for the two schemes for size change, namely fixed height variable width and fixed width variable height. The simulation have demonstrated that the latter scheme offers a lower phase slope. Number two, the performance of the bow tie unit cell was compared with the other shapes such as rectangle, dipole, and square, where it was found that the bow tie offers a large phase range, while they at the same time have a slightly larger phase slope compared to the dipole. The rectangle and square offered a smaller phase slope and lower phase range. This can be attributed to the fact that the bow tie has sharp edges compared to the rectangle and square shapes.
Uh, Hello, Rosalie. Can you hear me? Hello. Hello, Rosalie.
Rosalie ma'am, are you present in the Zoom meet?
Yes,
Actually,
Yes, yes.
Varsha ma'am are asking questions.
yes.
Yes. What was the if when you change the height and the width, what was the effect on the angle theta?
Um, mm, again, question.
You change the height and the width, isn't it?
Understand your questions.
We are not understanding. Okay, what are the applications of your research?
Mm.
Applications.
Okay. In the satellite and remote sensing application and other application.
Yes. Okay, thank you, Rosal. Your presentation was very nice.
Thank you.
Presented it. Yes, yes. Thank you very much.
Thank you ma'am for the presentation. Now we'll proceed to the next presentation. I request Nitish Kumar sir, if you're
Yeah,
present in the Zoom meet,
yeah,
you may start with your presentation.
yeah. Hey everyone. Let me just share my screen.
Yes.
Is my screen visible?
Yes, yes.
Okay, I'll start. So, good morning, everyone. Thank you for joining us today. I am Ovi, and I, along with my co-authors Nitish, Sai Santosh, and Arya, are going to present our work on building an adaptive neurofuzzy inference system that is also called ANFIS for enhancing 3D brain reconstructions of MRI scans. So we all know that MRI scans serve as a fundamental diagnostic tool, which is utilized by medical professionals worldwide. However, the accuracy of diagnosis and its treatment outcomes hinge greatly on the quality of resolution of images obtained and its precision. But these images often suffer from random noise pollution during maybe the image acquisition and transmission, which of course impairs the disease diagnosis by doctors or even automated systems. So our aim here is to introduce a paradigm shift in the way these reconstructions are accomplished by developing and improving the ANFIS framework for enhancement of these brain MRI reconstructions. Can you go to the next slide? Yeah. So coming to our motivation, I'm going to talk a little about the ANFIS and its characteristics. So ANFIS mainly comprises of, we can largely say of two modules, fuzzy logic and neural network techniques. So fuzzy logic can be used to recognize minute discrepancies in the tissues, which is of course very crucial factor in achieving a precise 3D model. And the neuroadaptive learning component enables the system to enhance its performance gradually. So with each succeeding scans, it can improve its performance. So ANFIS thus has a great potential to denoise and immensely enhance the precision of reconstruction process, as it will handle imprecise inputs, acquire knowledge from the data, and will utilize fuzzy logic to make judgments, simply like imitating a human decision making. Let's look at the existing methods. Existing methods demand heavy computational resources and also suffer from noise sensitivity and produce very limited resolution. This actually impacts the diagnostic precision as well. So our proposed ANSYS framework synergizes the strengths of neural networks and fuzzy logic, as I mentioned before, and it offers a robust solution to all these challenges.
Okay, thank you, Ovi. So let's see about the proposed system first. The first point here talks about the innovative approach that we have used in our research, which is ANFIS, which is a system that elevates 3D brain reconstruction by combining fuzzy logics, and which also enhances the precision of medical imaging. And the second point here talks about the hybrid learning that we have used, where the system employs a hybrid learning method to meticulously refine image classification and mitigate noise, which is the main factor that we are considering over here, and which leads to highly accurate tissue segmentation from the MRI data. And the third point says about the medical impact that we have had, that we are from this research, which states that like where our system enhances the neurological diagnostics and personalized medicine, which offers a transformative tool for medical practitioners and researchers. And let's see about the architecture diagram first. This comprises of several layers, where the first layer is the input layer. The input layer takes the pre-processed MRI data as its input, and there will be a process that happens over here, which is called as fuzzification, which allows for handling the uncertainties in MRI data by expressing the input data in terms of degrees of membership, which reflect how much of each input belongs to different fuzzy sets. The second layer is the rules layer. The rules layer will use a set of fuzzy if-then rules to process the fuzzy inputs, where each rule corresponds to a specific brain tissue characteristic and has a certain firing strength. And these rules are learned from the data that we have used and are used to generate a fuzzy result for each possible outcome. And we represent it using the value of pi, which multiplies the incoming signal and sends the product out. For example, if x is a1 and y is b1, then the rule strength is equal to the product of a1 and b1's membership function. The third layer is the normalization layer, where we represent it with the letter n. which normalize the firing strength from the previous layer. Normalization usually ensures that the sum of the firing strength is equal to 1, which allows for the combination of the rules output in a balanced way, making sure that the no single rule will influence the other results. The fourth layer is the defuzzification layer, where each neuron has here performs the computation of W1 into F1 or W2 into F2, where W is the normalized firing strength and F is the parameter set. This layer converts the fuzzy results from the rules layer into a crisp value. And the final layer is the output layer, where this layer sums all the incoming signals to produce the final output. This is the defuzzified result of the ANFIS structure. ANFIS structure. And yeah. So now let's see about the list of models in this research. And the first one is the data preprocessing. The second one is the ANFIS model training, and the third one, final one, is the result and evaluation. In data processing, like in our study, we have utilized the subset of MRI images from the EADNA database, which stands for Alzheimer's Disease Neuroimaging Initiative database, which is a rich dataset aimed at aiding research in Alzheimer's. Like the dataset has like 5,050 images in it, and we have divided into like 5,050 three distinct categories. The first one is the AD, which stands for Alzheimer's disease, and the second one is the CI, which is for mild cognitive impairment, and the third one is the cognitive normal. So to train our ANFIS model, we have used a balanced selection of all these three parts, which like AD has 1700, CI has 1690, and CN has 1660. This balanced approach ensures that the model doesn't become biased toward any particular category and can accurately distinguish between these three crucial stages of cognitive health. Lastly, we pre-process the images by normalizing the pixel intensity and resizing them to a uniform dimensions. Now let's see about the architecture that we have used for the data preprocessing. The first step is the data collection, where we collect MRI images for the study, which involves acquiring data from the database. And the second one is the quality assessment, where each collected image is then assessed for quality. This may involve like checking for clarity, ensuring that there is no corruption in the data, and confirming that the image meets the necessary criteria for our research. And the next one is pre-processing. Like pre-processing is divided into two parts. The first one is normalization, and the other one is the resizing. So normalization generally means like where the pixel intensity values falls between a range of 0 and 1, so that it will be like same for everything. And in the resizing part, we have the images to be distributed into a pixels of 256 into 256, this so that there will be a uniformity again with everything. And the next one is dataset partitioning. Like yeah, so after pre-processing, the dataset is partitioned into three parts, where it is like training, validation, and test set. The partitioning is crucial for our research because like we have trained the model, right? So it will be useful for us to evaluate the entire model. And the next one is the model training. With the data partition, the ANFIS model is trained into our data training set. Like it learns to classify images based on the features extracted from the pre-processing steps. And the next one is classification, where the model will be able to classify all the images based such as like EAD, CI, and CN from what it has learned. And the next one is results. Now let's see about like how we trained our model. Yeah, so the MRI images undergo normalization and resizing to create a standardized input format, which is crucial for maintaining consistency. Then we configure the model training through epochs, which is like iterations of learning. We do it continuously. And the next comes the learning rate, where we test how quickly the model can learn. And finally, the fuzzy inference system, which utilizes the membership functions to interpret the input data for pattern recognition. And finally, the ANFIS employs an iterative learning process to classify MRI images into AD, CI, and CN, where it enhances the parameters to improve classification accuracy. Now let's see about the architecture of our ANFIS model. So the ANFIS model has the input layer, which receives the preprocessed MRI data from the database. And then the input values are then converted into fuzzy values based on the degrees of membership. And then in rules layer, the fuzzy values are processed using fuzzy logic rules to make the decisions, like whether it is the ADCA or CN. And after it, it goes to a normalization layer where it basically normalizes rule strength, like the output from rules layer are normalized to ensure equal contribution to the final decision. And then it goes to defuzzification layer where it converts it into a value, and then it goes to output layer where it gives the final result.
Thanks, Nitish. So here, after having validated the effectiveness of our approach, we are presenting our findings. So ANFIS brings to the table an innovative combination of neural networks and fuzzy logic to provide a significant improvement in image resolution and noise reduction. And it can also be seen that it outperforms traditional methods in terms of accuracy, precision, and F1 score. Collectively, all of these have enabled ANFIS to have a better impact on medical diagnostics and patient care. Next slide. So if we take a look at this comparison chart, which is built across the three criteria shown, first point, we can say conventional methods are not able to handle the data variability well, which can lead to inaccuracies. So ANFIS employs advanced optimization methods to overcome this problem. Next up, the traditional methods resort to simple transformation techniques which lead to loss of fine details, which are in fact very crucial for the reconstruction. So ANFIS's rule bases preserve these high resolution details and they generate a precise output. Additionally, last point, in the traditional methods, they often rely on additional noise reduction algorithms, whereas the fuzzy logic within ANFIS handles this ambiguous data effectively and maintains the performance in noisy environments. So looking ahead, we envision further advancements in our system. This includes enhancing the accuracy and clinical utility of the model to potentially expand its application to other neuroimaging modalities. And we would also like to explore the adaptability of this approach to broader medical applications for the overall improvement of treatment planning. And the upcoming milestone of our research will be to integrate deep learning with ANFIS so that we can harness the strengths of both of these techniques for refining the 3D brain imaging process and its analysis. Yeah, these are some of the references that were crucial in our project's foundation. Yeah, with that, we come to the end of the presentation. Thank you so much.
Thank you, ma'am, for your presentation. Now, ma'am, if you
Hello.
have any questions.
Yes, hello. Hello, Arya. Am I right? She's Arya, na?
Yes, ma'am.
Yes.
Yes. The presentation was really fantastic. You have worked really very nicely on your research. My question is have you worked with a real-time data set or you have downloaded from some repository?
Yeah. So, hi, ma'am. I'm Sai Santosh from the same group.
Yes,
So,
please.
yeah. So we have got this ADNI dataset subset from University of Southern California's official website or repository, you can say. So they are having a subset of this with a collection of 6,000, 10,000, and other kind of pre-processed images. And we have took that and applied our own techniques to pre-process these. And then we have made a research based on this.
Okay, that's very nice. But if some real-time data set, suppose if it's an Indian data set and the same algorithms or methods you're applying on it, will there be some changes? So I'm asking this question like it could be from any country, not only in India, but it could be from any country around the world. And your methodology is working to that accuracy when the new data set is given to your methods.
Yes. To answer this question, so actually we are yet to try this method on several kinds of data set, because for now we have just tried this with one single data set because of the limitations which we have with our hardware and other things. But if we get the chance, like we would like to try this in multiple data sets, so that we'll be getting a more generalized model. So End of the day, our goal is to get a generalized model, right? Which will work better with all kinds of data. So the
Yes,
crucial
yes.
part in our project is MRI scans. So MRI scans being very general all over the world, I think our project holds a good use case in the upcoming days, since we are even trying to integrate it along with deep learning.
Yes, yes, definitely, yes, Sai. But yes, there is a concept called as a model misconception. When new data, it does not work good on new data
Yes,
set.
yeah,
Yes,
correct.
yes. So everything of yours is really very good. But I would like to suggest this thing that if a real-time data set is given, okay, so you can work out on this also.
Yeah,
Thank you
sure,
very
sure.
much. Yes.
Thank you. Thank you.
Yes, Siddhi, you may continue.
Yes, ma'am. So the next presenter for today's session is ma'am Sylvia Moreno, ma'am. You're present in the meeting, and their paper
Yes, I'm
title is
here.
hello, ma'am.
Hello.
Uh, Development of an artificial intelligence based application to predict air quality and environmental comfort from design parameters in new buildings. Ma'am, I would want to request you to continue with your presentation. I'll stop sharing my screen.
Okay, let me share my screen. Can you see my presentation?
Yes, ma'am. Yes.
Okay, good afternoon, everyone. My name is Silvia Moreno, and today I'm going to present our work, development of an artificial intelligence-based application to predict air quality and environmental comfort from design parameters in new buildings. This work was developed by Silvia Moreno, Reinaldo Villarreal, John Saavedra, Yolanda Vega Sampaio, Cindy Chamorro Solano, Heidi Rivera, and Alejandro Espejo. This is a collaboration between the bioclimatics consulting firm Biotecta, the Simón Bolívar University, and the National Learning Service of Colombia, SENA. In this presentation, I'm going to talk a little about what is the motivation behind our work, a brief introduction, what our main objectives were, some previous work, materials and methods, results, and conclusions. So what is the motivation behind our work? Climate change refers to the long-term alterations of world temperature and weather patterns. Since the 19th century, the development of human activities has played a leading role in driving this change, mainly due to the combustion of fossil fuels such as coal, oil, and gas. The consequences of climate change, as reported by the United Nations in 2022, include severe droughts, water shortages, devastating fires, rising sea levels, floods, polar melting, catastrophic storms, and loss of biodiversity. The implementation of artificial air conditioning systems is a factor that also contributes significantly to the increase in greenhouse gas emissions, which has led to the search for alternatives that allow reducing energy consumption and the carbon footprint in new constructions. In this context, the concept of bioclimatics has emerged, a discipline that takes advantage of natural environmental conditions to improve comfort in buildings from the architectural design phase. However, availability of bioclimatic experts is limited, especially in countries such as Colombia. On the other hand, the design and effective planning of ventilation systems and air conditioning are essential aspects of maintaining an optimal indoor environment. However, finding the balance between energy efficiency and human comfort is a multifaceted challenge. Artificial intelligence appears as a promising tool to change the way that we approach these complex challenges. Since AI can analyze big data sets and identify non-obvious patterns, it facilitates the proposal of customized solutions for air quality and comfort optimization in indoor spaces. In this work, we propose an AI-based method to predict air quality and environmental comfort from design parameters in new buildings. After developing this model, we embed this model into a friendly user interface as a web platform and we validate our model. What is our main objective? To develop a computational tool that predicts environmental comfort and air quality in buildings from the design stage with the purpose of enhancing quality and minimizing the environmental impact in future urban projects. Our specific objectives are to optimize the predictive model of the company Biotecta and estimate comfort levels and air quality based on design parameters by applying artificial intelligence techniques. Second, to develop a practical and friendly computational tool that allows evaluating the level of comfort and air quality of a design by applying the predictive model of the company Biotecta. And third, to validate the performance and usability of the tool with a group of potential users and refine the platform based on their feedback. There has been some previous work about bioclimatic analysis tools. For example, Solen, proposed by Miguel, it's a tool that is not available commercially, but it has the disadvantage that it requires a 3D model to perform the analysis. BCchart, proposed by Koshira and Pashek, is also not available commercially. It analyzes general locations and does not take design parameters into account. The bioclimatic analysis tool by Martinez and Freixanet is based on a spreadsheet. It does not have a friendly and scalable interface. In the works that we developed, we propose a model, a system with an easy interface where you can input several design parameters in a form, so you don't need a 3D model. Also, it takes into account architectural design aspects, and also it's developed on a web platform, so it has a friendly and scalable interface. What was the process that we followed? We had 3 stages: predictive model optimization, software predictive model development, and software validation. In the first stage, we took the model from the mathematical model from the company Biotecta, and we enhanced it with machine learning techniques. For this, we had an activity first where we create a data set, the train and test data sets from the knowledge experience of the company Biotecta. Then we assess the current model with the standard metrics, and then we try several classification algorithms to enhance this model. We tried support vector machine, random forest, and neural networks. This we use the language Python to try these methods and the library scikit-learn. From these models, the best one was the one with random forest and the one that continued to the second stage. In the software with predictive model development, we had activities of definition of requirements, software design, and software coding. To code the web platform, we use the Python-based framework Django. And for the software validation, we perform several lab tests, then a field test with potential users, and we use this input for prototype refinement. Our validation process had 3 stages. First, the evaluation of the base model, then the evaluation of the optimized model with machine learning techniques, and finally, the evaluation of the web platform. For the first stage, a dataset of 315 cases conducted by the firm Biotecta was collected. Of each case, 18 design parameters were specified and an additional variable of air quality that took 2 possible values, appropriate or inappropriate. In the dataset, 177 cases were classified as appropriate and 138 cases were classified as inappropriate. The dataset was divided into 90% for training and 10% for testing. The test dataset consisted of 32 cases, from which 50%, 16 cases, were categorized as appropriate and 50% were categorized as inappropriate. We use 18 input variables for our models from different architectural design parameters. These variables were total number of bathrooms or laundry rooms per building, total area of interconnected spaces, volume in cubic meters of the analyzed space, number of changes per hour of required renovation, design simultaneity percentage, external temperature, internal temperature, installation height, duct pressure differential, rust duct area, upper vent efficiency, net duct area, number of spaces for ventilation, total window area by type, total net area, bend height, bend pressure differential, and total verification load. For the validation of the integration of the model with the software interface, a subset of 289 test cases from the Enterprise Biodata were selected. In each case, the previously described 18 variables were collected, plus an additional variable for air quality that takes two values, appropriate or inappropriate. From these 289 cases, 169 were classified as appropriate, and around 120, around 42%, were categorized as inappropriate. In the laboratory test process, the value of the parameters were introduced in the web application, and the consistency between the predictions of the web application, the prediction of the base model, and the real measurements results were tested. To evaluate our models, we use the confusion metrics. This is a table where in the columns there is the predicted values. There are the predicted values, and in the rows there are the actual or the real values. From this, our observations can be classified into one of four categories: true positives, true negatives, false negatives, and false positives. From these confusion metrics, there are other metrics that are derived, such as accuracy, which is the percentage of correctly classified observations, sensitivity, specificity, precision, and F1 score. So what are our results? In the base model evaluation, we had that we only had 3 incorrectly classified cases, which gave us an accuracy of 0.906, which this is a very good result. However, they decided to improve it with machine learning techniques. And in the optimized model evaluation, we had a perfect classification with with 0 incorrect classified instances, and an accuracy of 1 and an F1 score of 1, a perfect classification. Then we integrated this model into the web platform, and we only had 1 incorrectly classified observation. And after doing some research, we find that the error was not of the model, but a mistake in the temperature database. So, and the accuracy of this model was 0.997, and then F1 score of 0.997, which is an almost perfect score. Conclusions. In the evaluation of the initial model, it was observed that the original model has an accuracy of almost 91%, which can be considered a good percentage. From this percentage, it is observed that the model is more effective in classifying positive cases, 93%, and has a slightly less good performance for negative cases, 87%. Although the model was quite good, machine learning techniques were applied to increase the performance, and it was improved up to 100% accuracy. In the case of the evaluation of the web platform with the integrated model, it can be observed that the number of cases correctly classified by the application is almost 100%. Only one of the cases was incorrectly classified. The development of this work demonstrates how AI can be applied to generate mathematical models that will allow predicting the behavior of real-world situations. In this case, predicting environmental comfort based on design parameters, and that with sufficient information and proper techniques, these models can be quite reliable. The development of this application will lead to more companies building environmentally friendly buildings and saving resources that would normally be used in artificial air conditioning, reducing the carbon footprint caused by these urban projects. All this contributes to the development of much more sustainable and efficient communities. Thank you. This is my presentation. I listen to your questions.
Yes, thank you, Sylvia. Yes, your presentation and your work is based upon a real-time data set. Is it?
Yes. It's a
Yes,
data
yes.
set that was collected by the company Biotecta.
Okay. So is the company satisfied with what you got the results?
Yes, they are very satisfied, and they are currently using the web platform to perform their analysis with new projects.
So how did you perform cross-validation?
No, we didn't do cross-validation. We only work with the
Yes.
data with
Yes,
Biodata,
if
and we
the
use
company,
a fixed train and test data set, but it would be a good
yes,
idea
if
to
the
try
if the
cross-validation.
company is satisfied So there some justification should be needed, or you should come out with some sentence or a cross validation point that how the company is satisfied there. Is it?
Okay. Okay. Well,
Yes.
I
Yes.
you are correct. Well, I guess I think
Yes.
I
So
consider that it's
only
satisfied because they
merely,
are using the tool, but I guess
yes, yes.
well,
It should be mentioned somewhere. It should be mentioned somewhere with some justification. So
okay.
it's really good. It's really a very, very excellent work, and companies using it, it's really very nice. But somewhere you need to justify it that yes, the company is using it, or you can get some statement from the company that yes, the work is being used and implemented there. So
Okay.
that
I
cross thing
mean,
it should be. Yes. Thank you very much. It was really an excellent work.
thank you.
Thank you so much, ma'am. Now we'll proceed to the next presentation.
Sorry, I can't close. I can open my.
Now the next presenter of today's session is Rohan Tikotekar. Sir, if you're present in the meet,
Yes. I'll just start it.
okay, you may start with your presentation.
Okay, sure. Is the screen visible?
Yes, yes, Rohan.
Okay, thank you. Okay, so hello and good evening to everyone. My name is Rohan Tikotekar, and today I will be presenting the paper Facial Detection and Recognition of Partially Occluded and Profile Faces. The members who contributed in this paper are myself, Mr. Rohan Tikotekar, Mr. Shaunak Kodbole, Mr. Ayush Kumbare, and Dr. Praveen Futani. All the members are from Vishwakarma Institute of Information Technology, Pune, India. So we'll move to the next slide. So here a table of contents are given. So if the first is the purpose statement, where we define that what is the problem statement which we have chosen and what problems we have addressed. The second one is the abstract, where we have introduced our like research paper and our basic approach. The third is the literature review, where we have analyzed the current research papers on these topics. We have also analyzed that which all gaps are present, and we have tried to address those. In the fourth one, we have given our method, like what new approach we have followed and what new contributions we are making to the research community. And the fifth one is the output of our machine learning model, and sixth one is the conclusion and the future work which could be carried out in this field. So we'll move to the next slide. So what is facial recognition and detection? So it is basically a computer vision method and a software which is used to identify faces based on the images which are stored in a machine learning model. So there are currently various machine learning models. The models which come under the deep learning category are ResNet, DeepNet, and various kinds of CNNs. So basically, we observed that the accuracy of these models was lying around 65% to 95%. And these models were facing quite some challenges, such as partial occlusion of the face, like the face was not completely visible to the camera, and hence the camera was not able to determine that the person is present in the image. And some other factors were like the brightness was not that good, and the lighting was not even in the image, and hence the model was not able to detect that which face is present in the image. So we tried to address all these challenges in our research paper. So this is the abstract. So we have used convolutional neural networks, generative adversarial networks, and Haar cascades. So here Haar cascades are used for facial recognition. Then GANs are used for sharpening the faces, for like sharpening the image, and CNNs are used for facial detection. So basically, we observed that only that the current research papers only focused on the frontal photos. So what we tried to address was we tried to include the profile photos as well as partially occluded photos, as well as some photos which have in which the in which the lighting was not even, and the application was in classrooms because we all are students, so we tried to create a data set from scratch yeah, from the CCTV footage in our classroom. But this application can be carried out in like any public place, which can be like office or places such as traffic signals, etc. So we'll move on. So in total, we referred around 17 research papers, but for this presentation, I've just considered 4 papers. So the first paper basically focused on support vector machines, and the accuracy which was observed was 74%. So here basically the main cause for this was that the CCTV footage was of very low quality, and hence the faces were not captured that well. The second one is the k-means. The second one is basically the researchers in this paper used k-means clustering and support vector machines. They had an accuracy of 93%, but the drawback here was that the extracted facial features were not that much. So we tried to improve on that as well. Then the third paper basically focused on the LBPH algorithm and higher cascades, which we have also used. But their accuracy was just 60% and the false positive rate was 30%, which was quite a lot. So we tried to like reduce the false positive rate as well. And the fourth paper, used orthogonal design of experiments, and they used deep CNN. And the application of this paper was also done in the classrooms, which we have also done, and their accuracy was 86%. So now we come to the proposed methodology, like what new approach we followed in this research paper. So first we take an arbitrary size input image. So basically what we did was there was one CCTV camera which was placed in our classroom. So the lecture basically spans for around like 60 minutes. So after every 15 minutes, we took one image. So in total, 4 images were captured. And the cameras have very low quality. So we tried, so first we checked that whether the image has 1080 pixels quality or not. So if the quality is not that great, then we went to the pattern split algorithm. So here what we did was we divided the image into patches of 64 by 64 pixels, and then we passed it to the GANs. So the generative adversarial networks focused on improving the quality. So the algorithm went from each patch and then it sharpened by using an unsharp mask. And all these new like images were stored in a separate database. Then after like splitting and then sharpening the image, we stitched the image, and then we passed it to the higher cascade classifiers for facial uh, for facial recognition. So like higher cascades were like responsible for like detecting the frontal faces, and the faces were, and the side profiles and all the like remaining profiles were captured by the CNNs. So here we can see that the CNNs can like detect the faces, and then they update that the student is present in the classroom. So 4 iterations are done in total, as I said, like every 15 minutes we took one snapshot from the camera, and then the data is updated. So like sometimes it can happen that the student is not there in the profile of the camera. So maybe we, and so the student can be like uh, can be like present in the second iteration. So in this way, no student is like missed in the image, in the frame, and thus the output is given. So now we'll see each step one by one. So in this, the input of the image was taken by a 704 by 480 pixels camera. So here the camera used also was not that great. So then we performed the patch and split method, in which we divided the image into 64 by 64 pixels for then passing it to the GAN. Then then comes the sharpening part. So we use so each patch was then sharpened by using an unsharp mask. So here basically we tried to compare 2 to 3 types of GANs. One was like lab SR GAN, one was like only just SR GAN, but the best results were obtained by like EDSR GAN, and hence we went ahead with that one. So we choose the this GAN for sharpening of the image and to improve its quality. Then all these patches were then split, and the database which was formed of new patches. So all these patches were like combined to form the enhanced image. So moving to the next slide. So here we'll see the input and output. So first was this image. So the camera captured this image, and after passing it through the GAN, this image was obtained. So here in these phases, we can clearly observe that the quality has like increased to quite some extent. So here what major problem was that the lighting was also not even, like some of these curtains were open, some were closed, and these faces were not visible. So here the quality of these faces have like improved significantly, and thus like 4 images were captured. Yeah. So here the GANs came into picture. Then the R cascade classifiers were used for the frontal profile detection, and the CNN model. Yeah, so the CNN model took total of 9 photos. So we'll check that in the next slide. Yeah. So here what we did was we took photos of every student from various angles. So this is the center profile, and these are the side profiles. The first row comes under the top view, then the second row comes under the frontal profile, and this comes from the bottom profile. So the camera is basically, sometimes the camera can be like located at some weird angle, so all these profiles are captured. So we took the photos of all the students, and we created our own database from our college. This is our final output. So here the faces are like detected. Here also these faces which are not clearly visible, so they are also like detected by the machine learning model. And so here in these posters also some false positive sorry, some sorry, some false positives are also captured. So that was one drawback, that the pictures of these posters were also captured. So the accuracy which we observed was like very good. So for facial recognition, the accuracy was 93.2%, and for facial detection, it was 96%. So the accuracy observed was very good compared to the earlier models. Some drawbacks of this model can be such that the computation which required was heavy, and, and the storage required was also a lot, because we checked the complete footage. Sorry. So yeah, these were some of the problems which we encountered, and further like research work can be focused on the storage part mostly. But the accuracy obtained was very good, which was 96% for facial recognition and 93.2% for facial detection. So these are the references which we used. So the total of 17 papers we referred. So yeah, thank you everyone for listening, and we are open for questions and discussions.
Yes, Rohan, it was an
Yes, ma'am.
excellent work performed by you.
Thank you, ma'am.
Yes, and you have also presented it in a very, very fantastic way. Yes, Rohan, my question is like, what was the parameters used to find the accuracy when you're using machine learning methods?
Ma'am, the parameters used were basically, so we basically counted the total students who were present in the classroom, and then we compared it with the output of the machine learning model. So almost like, so 96% of the faces were like analyzed by the
So,
model.
any accuracy measure, for
Accuracy
example,
measure
we are
was,
having some statistical measures also there. So, any accuracy measure which you have referred. So how can I
Accuracy.
say accuracy? Yes, accuracy is good. I
Okay.
can have F1 score, I can have specificity, I can have sensitivity, many things. But when you're saying accuracy, can you be more accurate for the measure?
For this, we just compared the total students present in the classroom at that point and the faces observed at that time. So just I think like three to four 3 to 4 faces were not like recognized by the model. Hence, we just subtracted it
And
from the
so
students.
many of the times it happens that few students they do not come to the class.
Right, right, right.
So in that case, the accuracy may go down there. Is
Right.
it so?
In that case, yeah. So those would be false negatives, right? The students
False
were not
negative.
present. Yeah. So in that case, it can be addressed. Then the accuracy could go down. Yes, yes, true.
Yes, yes. I think we you should study a little bit more
But
on that.
right, right.
Yes. Yes, one more thing is like a few students, especially the male students, sometimes they have beard, sometimes they do not
Right,
have, and girls also sometimes they may have haircut. So
right,
what is the impact or the facial emotions which they are having? So
right,
what
right.
is the impact of that?
So we have basically considered 9 angles in total, and I'll
Hmm.
just also show like how we went here. Um, So yeah, so we have basically considered all these 9 angles of the picture, as well as we have considered 4 more angles. So like in the central picture, we like split the image into 2 halves. First, we like divided it vertically, and second we divided it horizontally. So here also the all these images, like all the facial features in detail. So they were also they were also used in the data set for training the model. So like
Total, how many facial features you have used,
total
and how many should be correct so as to identify it that this input image is correctly identified.
the total images for each person were used were 13, and for correct image, the model tried to like check based on the facial features than these parameters like hair and beard. So like based on his eyes
Okay,
and
okay.
nose, all these things were considered.
Excellent, excellent, Ron. Very, very, very excellent work.
Thank you, ma'am. Thank you. Thank you.
Thank you.
Okay, I'll just stop sharing.
Yes, yes, Siddhi.
Thank you, Rohan. You may stop sharing the screen now. Okay. So the next presenter is Yaroslav sir. If you're present in the session, please let me know.
Yes, I'm here. Hello.
Okay. Hello, sir. You may start with your presentation now. I'll stop sharing my screen.
Okay. Do you see my presentation?
Yes, we can see your presentation.
Okay, good. Just a second. Okay, so I would present our work and the main contributors to it is Vasily Yurchishin from National University, Technical University of Ukraine, Kiev Polytechnic Institute, and me. And there is not much information that is presented here. And I hope you see presentation, not the text right now, right? Do you hear me? Sorry. Do you see the presentation
Yes,
or
yes,
text?
yes, yes. Yes, yes, yes. We can hear you. Also, we can see your presentation.
Presentation. Okay, thanks. Because I'm
Yeah.
switching between different program. So there is not so much information that is presented in the presentation because we want to share our general idea as such rather than to show any kind of test results or researches. So modeling of living matter is of great importance for biology, medical science, the technical sciences, and science in general. And these issues remain complex and have not been explored to the necessary extent as we think. And as technical specialists, our attention continues to be attracted by the general system of a living organism as a complex mechanism with striking analogies with technical devices and the peculiarities of their operation. So we are convinced that such questions are of interest to many scientists. At the same time, we believe that many technical developments can be used in modeling a living organism, determining its condition and more accurately diagnosing deviations from generally accepted concepts about the physical state of the human body. Our our opinion is the opinion of scientists of purely technical orientation rather than medical specialists. In this case, we consider this issue not as a medical system, but as a physical one, and we are proposing to consider it in this aspect. We are considering a human being as a biological type of computer. We are not criticizing all known developments in these matters, but we perceive them as a proven and irrefutable fact and rely on them. For us, a living organism is a complex mechanism which is not easy to understand in its various manifestations, but it may be helpful to model it using knowledge of the characteristics of other complex mechanisms. And we view the human body as an actual complex computer system. We believe that the existing developments in this area can be significantly help in solving urgent related issues on other areas of human activity. We are not presenting any results of experiments and studies for discussion. This is our perception of the current state of affairs in this field, and we are presenting our opinions for discussion. Here we would like to consider the system of a living organism as a physical system and look at the model of its functions in another way, namely in terms of information and programming. We are not going to review the established models of biological systems. So, viewing the human body as a system, we see that it operates according to the principle of a computer of elements. It may be noted that this was been known for a long time. It has undergone many developments. And we accept this, but it is not what we are talking about here. We are talking about the use by humans of purely computer-based manifestations in their practical activities from the beginning of their birth and until their departure from this life. We use words without worrying or thinking about this action as such. What is it? Among the multiple of definitions that human language as such is primarily code. Similar to computer code, letters, words, and phrases have certain code combinations, and computer operation is based on the use of code combinations. Human language also takes the form of code combinations. It can be argued that all living things use encoded information to communicate in one way or another, and it is different for all species. And for such species of living beings as humans, language is different depending on its location on Earth. The situation in this regard greatly resembles the period in which the first personal computers emerged, when many companies sculpted their, so to say, their personal components of their own design and with their own hardware components. And there was no question of standardization and unification. Some of them had more advanced designs and others were much simpler and more primitive. For communication, humans have been given their language. Let us take a closer look at what that is like. To us, human language is strikingly similar to the high-level language of modern computer. There are a huge number of programming languages nowadays, and there are as many human languages as there are computer languages. A high-level programming language is used in the computer, but it does not directly make those final switches in the final elements of the computer itself, in which elementary operations such as addition, multiplication, division, entry, locking, etc. take place. This is what the compilation process is for. A compiler is a program that reads the text of a program written in one language, the source language, and translates it into an equivalent text in another language, the target language. To put it simply, a compiler is a translator for which the input language is a high-level language and the output language is the machine command language, or even more simply, a set of electrical signals that turn on and off the final electronic elements of the computer during its operation. It happens in a similar way in a living organism. And here the main task is to follow the human compilation to the final level. How does the code "give me some water" make us get up, take a cup, pour some water into it, and bring it to the specified address? And where are these final gates similar to a computer in a living organism? How exactly do we turn them on and off? In this regard, we need to carefully understand, if possible, follow and compare everything with purely technical analogies at the level of familiar and understandable diagrams. Because despite the colossal achievements in the studies of living organisms, which we greatly admire, we believe that there are many assumptions and inconsistencies within these issues. In a computer, we can precisely take the path from code combination in high-level computer language to its particular final electronic element of a final gate. We can depict both a model and a complete electrical kinematic and assembly diagram. If we can do the same for a living organism from words to action, but to reflect this process with a complete analogy of electrical, kinematic, and assembly diagrams of computer, then it will be easier for us to create new, more advanced technical creatures and successfully overcome both existing and new diseases of the human body. Because in a living organism, not everything is clear as it seems. Everything, existing ideas about the functioning of a living organism may not always correspond to reality. There are many opinions that differ from the accepted ideas. How should we start with this work? We should think first of all of focusing on more understandable and acceptable analogies. For us, these energy issues and pathways of energy flows is the case. For us, these issues in the computer system are understandable. What is happening there and how it is happening at a certain specific moment. As for living organisms, there are also incredible developments and achievements, but we do not see any analogies here that are acceptable for us. If we return to the analogies of the pathways from the code combination in the high-level language of the computer system to its final electronic element, and the pathways of propagation of an action from the word or thought to the final execution, then for us a more acceptable analogy is between the electrical network of a computer and the circulatory system of a living organism. Not in the literal sense of what was said, but in the most approximate sense. What exactly do we see in it? We see it in the relationship of systems. We perceive that in today's realities, this is a question of neurophysics and neurobiology. Their achievements are incredible and impressive, but here we want to draw attention to something else, namely to the role of blood and the circulatory system to processes from the word to the final concrete action of a living organism. We believe that this process is so multifaceted that it is very easy to overlook the most important things. We believe that the determining factor in movements in a living organism is blood. Similarly, electric current is decisive in the operation of electrical systems. We see it primarily in the nature of the movement itself. We perceive the huge number of studies of blood dynamics in a living organism as very important, but in our opinion, they do not reflect all manifestations of its phenomenon. Water flows in a water pipe, similarly to the leakage of water from a bath tube, in the form of a vortex, despite the fact that we see such a leak as a continuous flow of water when it leaks from a pipe. Electric current flows in a conductor in a similar way. That is why when modeling a living organism, we suggest paying attention to the circulatory system and the peculiarities of blood flow. The circulatory system maintains this necessary body temperature. When blood circulation stops, body temperature drops and a person begins to freeze. This is how a person dies after falling asleep in the cold. Loss of consciousness prevents a message being sent to stop the decrease in body temperature by additional movements, thermal insulation of the body with a blanket or some liquid, or moving the body to a warmer place. And what is important is that the necessary temperature of a living body is maintained not only due to the metabolism of nutrients which the blood carries to the body organs. For us, computer system corresponds most of all to the circulatory system of a living organism. Both systems are closed, and the movement of currents of electric carriers in a computer and the movement of blood in a living organism are strikingly similar to this. When we analyze the above, the following question arises: in what code does nature work? When we look at computer engineering equipment from Pascal, Leibniz, Babbage to the present day, we can see a clearly visible milestone that cannot be overlooked. In our opinion, this milestone is the application of binary coding. The use of binary coding allowed Babbage's bulky analytical machine, the size of a steam locomotive, to be reduced to the size of a table with an area of about 2 square meters. We would call this milestone the first computer revolution. And what code is the basis for the functioning of a living organism? We assume that a living organism does not operate on the basis of a binary code, but a living organism uses elements of binary coding in its work. We are convinced that all living things are based on national principles. The electron we most commonly use is actually a vortex, an energy vortex. In the laws of vortex functioning, there are both manifestations of rotation and duality. This is a movement in a circle, namely rotational, which has a certain diameter or radius. And this is clearly visible to us both in Niels Bohr quantization and in the laws of quantum physics. The issues discussed were undeliberately debatable, but they are timely. What should be done to resolve them? At the least, a computer engineering specialist, a software engineering specialist, and a medical specialist or biologist should sit side by side. Norbert Wiener, who is the undisputed founder of cybernetics as a science, was the first person to point out the relationship between man and machine. His approaches to science as such take in account of various aspects, namely the purely scientific, social, and religious aspects are especially impressive. Returning to the statement that living beings speak in code and that their language, by analogy with a computer, is a high-level language, a valid question arises. What organ of a living organism performs the function of a compiler? We believe it is a brain. If it has a memory function, it is extremely limited. Its main function is to establish connections. And the most interesting discoveries in human informatization will be found at the intersecting points of many sciences and by the efforts of multidisciplinary specialists in various fields of knowledge. That's it from my side. Thank you.
Yes, Yaroslav, am I right?
Yes, yes,
Yes,
Yaroslav.
yes. Yaroslav, you have presented it very nicely. Only within 4 slides, you have given an excellent presentation that the complete thing was an understanding part here. What was the conclusion of your research?
Our conclusion is that we force the scientific society to think about our idea and to perform further researches, investigations, and to make further developments in this area. So our aim is to bring the idea to the scientific society, and we think it should be done in such a way as today.
Yes, yes, excellent. Thank you very much.
Thank you. Thank you too.
Thank you, sir, for your presentation. Now, next we'll proceed to the last presentation of today's session. I welcome Nasir Zahiri, sir, to start presenting.
Hello.
Hello.
Thank you. Thank you, Dr. Jadef. Um, Good afternoon, ladies and gentlemen, colleagues. Glad to be with you to present our work. I'll stop the video and try to share my screen with you. Please let me know that my screen is available. So you can see it, yeah, I believe, yes?
Yes, sir, we can see your screen. You may start with
Thank
your
you.
presentation.
Thank you. Thank you. Due to time limitation and what time left, we'll try to stick with the time left. In this presentation, we will present our preliminary result of a project that been implemented by my colleagues, Hassan, Fatma, and myself, Nasser. The idea of this is to try to present the work of implementing a smart solar energy management system using Wi-Fi wireless communication. I will go through these points, give a brief theoretical background, and then present the proposed architecture and the simulation experimental result that we have obtained up to the moment. And then I will conclude this work with some major ideas. Now, as we all know, that solar energy has attracted substantial attention from research and from different academic and industrial engineering and technology fields. Basically, this solar energy comes from radiant light, heat emitted from sun, and we try to harness this using various technologies such as solar heating, photovoltaic cells, solar thermal energy, and etc. And this work, actually, what we are going to present, we consider how to maximize the absorption of solar energy using photovoltaic cells. And for this, we built a smart architecture of hardware and software, as we said, based on PV cells, um, uh, basically controlled by wireless communication system, which is based on Wi-Fi technology. We have tried to make this presentation as simple as possible, but actually the paper has furnished a deep theoretical background regarding the generation of current out of PV cells. So for those who are interested in this, I would be glad to refer them to the paper so that they get more insight about the theoretical background behind this. But just to summarize the main ideas, the PV cells actually convert incident solar radiation energy into electrical energy by absorption of photons. These photons actually are collected at either side of a PV cell by metal contacts. Now, once absorption occurs, the electron will have enough energy to transit, to have this transition to the conduction band, which leaves behind a hole and effectively creating what we call EHP, electron hole pair. And this eventually will lead to a contribution of a photo current. Now, the major burden is the total or partial reflection of the incident photons of the cell surface. And that was actually the main idea of the work, that we try to minimize as much as possible the reflection so that we ensure a higher number of photons absorbed and ensure high eventually efficiency. Now, again, as I've said, the details, so much information or formulas, equations are presented in the paper, but I'm showing here only the final result of this analysis, which is basically based on the reflectance. The risk reflectance has two major components. One, we call it perpendicular, and the other one is the parallel or tangential. Given by these equations, we have let me just try to explain it here. We have this incident light, which basically traveling from one medium to another medium. So part of this light will be transmitted and part of it will be reflected back there. So at the maximum theoretical, if it is possible, we would like to have all of this incident to be reflected, to be transmitted fully to this medium and try to cancel this component, which is basically, this is very difficult to achieve. So we still have some part of this energy that is reflected back here. Now, going through this analysis, we can analyze this reflectance into two components, as we said. One of them, the call it parallel component, and the other one is the perpendicular one. And the total effect of this is measured by what is called reflectance. Now we have built a test bed solar tracker panel, which automatically is oriented toward the actual location of the sun. The idea of this, of course, to absorb as much possible light or heat as possible, so that we try to maximize, as we said, the light and eventually maximize the transmitted light. Now, we have a drive unit that controls DC servo motors to move the panel using 4 LDR, light dependent resistor, to provide us an analog signals, which is processed by basically a simple and low energy microcontroller, and actually we have used in this case Arduino. The system is supported by a communication block as it's needed wireless communication based on Wi-Fi IEEE 802.11. And also in this part, we have furnished a good background about the different versions of I 802.11, versions A, B, N, AH, AX, they're all there in the paper, but due to, again, time limitation and for the sake of making this presentation unboring, if I may say. So we have summarized this in general title. The idea of this that we measure energy, power, voltage, and current that was actually given or studied using this basically building a block. We have the basic control unit here, the Arduino, with the different sensors that we have, transmit the data through the control Arduino and through the LDR, with also the sensors that control the voltage and current here. This is transferred to servo meter, which eventually controls the movement of a solar panel. And all this data is controlled by two platforms. We have made two platforms, one for a mobile and one for a desktop, and all the data actually are saved in the database. We are showing here the test bed that we have created, as you see. Solar tracker mounted on moving surface following trajectory of the sun. The panel installed on an inclined plane moves according to the strength of light illumination using LDR. Eventually, LDR will generate an output voltage which is proportional to the input voltage, and it is by in turn proportional to a light intensity. Now, the resultant current is fed to the microcontroller as we see it there, which consequently delivers the adequate level of control needed to the servo motor, which in turn provide the necessary movement in response to the received current. We have proposed or presented two types of results. First, simulation through MATLAB, and then we have measured some experimental result to validate actually the simulation that we have obtained. As we see here, we are showing simulation of the effect of varying the incident angle of the incoming light on the reflectances for both components using the equations that have been shown in the previous slides, and equations also that are already furnished in the paper for the case of air silicon interface. And as we can see actually from this, which is expected eventually, is when the incident angle increases, the reflectance, of course, will increase. So we try to make it as much as possible perpendicular to the direction of incidence. Now, these are the two interfaces that we show. The first one for mobile phone, and the other one here, which is a much more sophisticated compared to the one of the mobile phone, which is basically the one that is used for desktop, showing details of temperature, current, voltage, and the power. So, as I promised to make it as fast as and quick as possible, we conclude this work and the presentation. And we say that we are presenting our preliminary results for smart solar energy management system. This work aims at absorbing maximum solar energy by continuously tracking the sun's direction. The proposed architecture comprises of, as we have seen, photovoltaic panel controlled by LDR and servo meter, and remotely controlled by a Wi-Fi technology. And we are planning at this level to maximize even the absorbed energy by what we intended to call a smart load distribution, which we hope that will represent this work and results in the future and upcoming conferences. And thank you. Thank you for listening. I'm willing to handle and have any questions from your side.
Yes, sir. It was an excellent work where physics was the base here.
Thank you.
So,
Thank you, ma'am.
yes, yes. Oh, what was the inspiration to start with this work, sir?
Actually, as you know, we live here in Kuwait. I believe you know the temperature here in Kuwait. How it's summer, the temperature rises up to 50 plus degrees. Even we don't have that much heavy winter. So it's we have a great chance to provide and support our electrical grid system with this amount of energy, what we call renewable energy. And of course, that's the aim of today's, even as you all, I'm sure, know, even the United Nations are taking so many initiatives in this regard, trying to push people and countries as much as possible to use these kind of renewable energy so that have positive effect on the environment and all of the eventual economical and social issues and impacts. Yes.
Yes, yes, yes. It's really nice. But I would also like to have one more question. That is, the heat, the sun heat is not equal throughout the earth. On the equator side and the poles, and on the poles on the earth, it's different. So in that case, how your project is going to work?
Exactly. This is also another issue that we have thought of. Now, the idea of this, so we try to propose a kind of a smart system so that it's an intelligent way, it tracks the location of the sun. So how much heat or temperature is actually increasing in which direction, and eventually the solar panel will orient itself in that direction. And this also we need to put into our consideration that also the material of the solar cell, size of the solar cell, the quantity also of this also has to be considered and taken into consideration in this regard. Eventually, there are so different parameters, and it will lead us to what we call optimization kind of problems that need to be considered in this regard. So again, this is what actually we have considered and meant by saying that we intend to propose a kind of a smart system for this. Yes.
Yes, yes. Thank you, sir. Very excellent work and presentation.
Thank you.
Thank you
Thank
very
you. Thank you so much.
Thank you, sir, for your presentation. Now I'll just give closing remarks and then we'll end the session. Okay. I sincerely thank our authors for their excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on the behalf of the whole team, thank you for the support during the ninth version and all the previous 8 versions of the conference. We will be happy to have you all in the 10th version in 2025. All the presenters would be getting their digital certificates via email within 2 working days. Further, all the papers have already been forwarded to the Springer. The publication will be live within 6 months. Kindly cooperate with the team of ICICT. I also would love to like to thank our session chair, Dr. Varsha Zadhav ma'am, for chairing the session. And I want to discuss the yes. First, I will for chairing the session and a token of
much. Thank you.
appreciation to the chair on behalf of Team ICICT, Global Knowledge Research Foundation and partners. Thank you all for your valuable presence. And before concluding the meeting and ending the session, I have a small request to all the participants and the chair of the session to please turn on your camera so that I can take a quick snapshot.
I'm just having one question, if you may allow me.
Nitish, okay, okay.
Yeah, regarding the proceeding, you said that it will be
Nitish, sir,
available when?
it will be
The
available
conference
about
proceeding?
what are you asking? A
Yes, sir,
digital
the
certificate will
proceedings
be
will be
available
available in
within.
the Springer within 6 months.
Oh, 6 months. Okay.
Yes,
Yeah,
it
Okay.
will be live
it
within
takes
6
time. It
months,
takes
and the
time.
digital certificate you'll get in 2 working days.
Thank you. Thank you.
Okay, I'll just take a snapshot now. Thank you so much. Take care, and you may end the session now.
Thank you,
Thank you.
Siddhi. Thank you, Riddhi, madam.
Thank you.
Bye.